Alright, so before we go into the lesson for this, I do want to do a quick lesson on adding and subtracting, multiplying and dividing integers because it helps with the next lesson. So, adding and subtracting integers. Remember, when we're talking about integers, we're talking about positive and negative numbers, okay? So, right away here, when we go to add and subtract integers, right? If we are adding same signs, meaning I have like a positive plus a positive, right? Or a negative plus a negative. I basically add the numbers and carry the sign. Okay? So if I think about it this way, if I have -2 plus -3, think about it here. I have 2 negatives here. I have 3 negatives here. How many total negatives do I have? 5. So this would be -5. You'll also see the same problem written as -2 minus 3. Okay? Adding a negative is the same as just subtracting. Now, different signs. So say I have a positive plus a negative, right? Or say a positive minus a number, right? If I have different signs, okay, I basically subtract and take the sign I have more of. Okay? For instance, if I'm doing -4 plus 6, I have 4 negatives here. I have 6 positives, right? Remember, a negative and a positive wipe each other out. So what do I have left here at the end? I have 2 positives, so -4 plus 6 is +2, right? Or if I subtract, I get 2. I have 4 negatives, 6 positives. What do I have more of? Positives. So, looking at the examples down below, 6 plus 7 is just 13. That one should be easy, right? -5 plus -2, I have same signs, so I'm going to add them together and carry the sign. And think of it this way. I have 5 negatives, 2 negatives. How many total negatives? 7. -3 plus 8, different signs, so I'm going to subtract them. I have 3 negatives, 5 positives. What do I have more of? Positives. Over here, I have +6 plus -10, right? Different signs, so I'm going to subtract, get 4. I have 6 positives, 10 negatives. What do I have more of? Negatives. Therefore, it's a -4. 13 minus 8, you should see it's different signs, right? But you should be able to do 13 minus 8, no problem, it's just 5. Now, when I have -4 minus 6, that 4 is negative, 6 is negative, so I basically have same signs, so I add them together and I carry the sign. 7 minus 15, that's different signs. So if I were to subtract them, 15 minus 7 is 8. I have 7 positives, 15 negatives. What do I have more of? Negatives. So that would be -8. Then the last one, -8 minus 6, same signs. So I add them together. They're all negative, so it's -14. Okay? So adding and subtracting is a integers has very simple rules. You just have to know same or different signs. Now, multiplying or dividing. Same signs when you multiply is going to be a positive. Different signs would be a negative. Dividing is the same thing. If I divide same signs, it's positive. Different signs, it's negative. So right away here, +5 times +6. Same signs, multiplying together. You get a positive. Here, -7 times 9, different signs means it's negative. 7 times 9 is 63. Negative 5 times 8. A negative times a positive is a negative. 5 times 8 is 40. 5 times negative 4, different sign, so it's negative. 5 times 4 is negative 20. Now here, when we multiply two numbers at a time. So when I do negative 2 times negative 3, I get positive 6. Now, times positive 4 would give me 24. Negative 25 divided by negative 5. I have same sign, so it's going to be positive. And what is 25 divided by 5? 5. Positive 40 divided by negative 5. It's different sign, so it's negative. 40 divided by 5 is 8. And number 8. A negative divided by a positive is a negative. 120 divided by 10 is 12. Okay? So that's multiplying, dividing, right? Same signs is positive, different signs is a negative. Now, exponents. We talked about this a little bit. What happens with an exponent is you have some base raised to some exponent. And what the exponent tells you how many times you're going to multiply the base by itself. Exponent tells you how many times to multiply the base by itself. Okay, so in this case, 6 to the second power is the same as doing 6 times 6, which would give me 36. The second example, negative 3 to the second, is negative 3 times negative 3, which would give me positive 9. Number 3, 4 to the third power is 4 times 4 times 4. 4 times 4 is 16, times 4 would be 64. Okay, I hope you're catching on to the pattern. 2 to the fifth power would be 2 times 2 times 2 times 2 times 2. Now, this would give me 4 times this would give me 4 times 2. 4 times 4 is 16 times 2 would be 32. Okay, so evaluating exponential problems is pretty important. Now, an algebraic expression is what we've been dealing with so far. And this is basically a bunch of terms linked by addition or subtraction. So we've seen stuff like 4x squared plus 6x minus 3. This is an algebraic expression. 10 is an algebraic expression. 3x minus 1 is an algebraic expression. So anytime you have terms linked by addition or subtraction, you basically get an algebra expression. Now, an equation is basically when two expressions are set equal to each other. Alright? For instance, if I take an algebra expression 3x minus 1, set it equal to 4, that would be an example of an equation. Okay? Now, if I give you something like 4x squared plus 6x minus 1 equals 2x minus 5, this is an equation. Alright? Now, there's one thing I'm going to add to this. The solution to an equation is the value of the variable that makes the equation true. Okay? For instance, if I look at 3x plus 1 equals 13, and I tell you x equals 4 is the solution. This is the solution to this equation. If I plug 4 in, 3 times 4 plus 1 should make this a true statement. 3 times 4 is 12. 12 plus 1 is that 13? Yes. Therefore, 4 is the solution to that equation. All right. Now, how do we solve equations? We use inverse operations. So if I tell you an operation, an inverse operation is the operation we use to get rid of it. Okay? So for instance, if I tell you the operation is addition, the inverse operation is subtraction. If I tell you the operation is subtraction, the inverse operation is addition. If I tell you the operation is multiplication, the inverse of that is division. And if I tell you the operation is division, the inverse operation is multiplication. So when we solve equations, step 1 is, let's say the goal is to get the variable by itself. And basically to do this, we get rid of constants, meaning just numbers, the terms with no variables linked to it, right? Using inverse operations. Okay? So today is very easy, and we're going to go through a ton of examples, and I'm going to go through them fast so that you can always pause and rewind if you need to. Okay? So when I look at solving these equations, my goal is to get these variables by itself. Okay? That's my goal, to get the variable by itself. Which means, here's the thing. When I solve an equation, I have to get rid of the constant and bring it over. I'm bringing it over here. But in order to get rid of it here, right, if this is linked by addition, I have to subtract it on both sides. What I do to one side, I have to do to the other side. So what is 16 minus 16? 0. So I bring down my x equals 25 minus 16 is 9. Okay? So remember, what you do to one side, you have to do the same exact thing on the other side. And we need to show our work all the time. So here, it's x minus 5. Since 5 is negative, I'm going to get rid of it by adding 5. Because this should add up to 0 when I get rid of it. If I add 5 to this side, I add 5 to this side, and I bring down the x, bring down my equal sign. 12 plus 5 is 17. Think about it here. If I plug this 9 back in, is 9 plus 16 equal to 25? Yes. Is 17 minus 5 equal to 12? Yes. Number 3, how do I get rid of the minus 7? I add it. What I do to one side, I do to the other. Bring down my x, bring down my equal sign. Negative 9 plus 7. Different signs, so I subtract, I get 2. I have 9 negatives, 7 positive. I have more negatives, so x equals negative 2. Okay? Next one. X plus 10 equals negative 24. Since I'm adding 10, I'm going to subtract it on this side to get rid of it. Subtract it on the other side. Bring down my x equals, here, negative 24 minus 10. Same signs, add them together, carry my sign, and I would get x equals negative 34. In an example like number 5, right? Sometimes what I like to do is copy the side with the variable on the left. So I copy and paste it there, equals negative 14. So I just rewrote the problem so that now What do I have to get rid of to get n by itself? The negative 9. How do I get rid of it? Add 9. That adds up to 0. Gets rid of it. Add 9. N equals negative 14 plus 9. Different sign, so I subtract. I get 5. I have 14 negatives, 9 positives, so it's negative 5. Now the next one, right? Again, I like to copy the x plus 12. I write it down on the left side, equals. I bring this to the right side. And now, what do I have to do to get rid of 12? Since it's positive, I subtract it. Subtract it from the other side. Bring down my x, equals 52 minus 12 is 40. Number 7. This is where it gets a little tricky. That's 12 plus x. Is 12 positive or negative? It's positive. Therefore, to get rid of it, I'm going to subtract it. What do I have to do to this side? Subtract 12. Bring down my x. 13 minus 12 is 1. Now my next example, this is negative 6 plus x equals 8. If I look at this 6, it's negative, meaning to get rid of it, I have to add it. If I add 6 to the left side, I add 6 to the right side, bring down my x, 8 plus 6 is 14, and I am done. Alright, so all of these equations involve undoing, addition, or subtraction. So now we have to move on to multiplication or division. Remember, if it's linked by multiplication, the inverse operation is division. So this is 5 times k. Since these are linked by multiplication, how do I get rid of the 5? I divide by 5. Remember, what is 5 divided by 5 going to give me? 1. And 1 times k is just k. So that actually gets the variable by itself. What I do to one side, I do to the other. So 5k divided by 5 is k, equals 35 divided by 5 is 7. If I check my solution, 5 times 7 is 35. That checks out. Next one, negative 6 times x equals 42. How do I get rid of negative 6? Divide. Whatever I do to this side, I do to that side. X equals 42 divided by negative 6. Positive divided by negative is a negative 7. Over here, divide by negative 7, divide by negative 7. Negative 63 divided by negative 7. Negative divided by negative is a positive 9. Over here again, rewrite the problem with the variable on the left. Negative 2x equals negative 16. Divide by negative 2. These cancel out. Negative 16 divided by negative 2 is positive 8. Now the next one, 12 times x equals 4. What do I have to get rid of to get x by itself? The 12. I undo it by division. I divide by 12. X equals 4 over 12 does not divide evenly, but we can reduce this fraction by dividing the numerator and denominator by the common factor to get 1/3. M is linked to 4 by division. So to undo division, I multiply. So to get rid of this 4, I'm going to multiply this by 4. These cancel out. What I do to the left side, I do to the right side. And negative 4 times 4, different sign, so it's negative 16. 15, right? As I do this one. X is linked to negative 6 by division. So to get rid of the negative 6, I multiply the left side. These cancel out. Multiply the right side by negative 6. And 3 times negative 6 is negative 18. X is linked to negative 8 by division. How do I get rid of it? Multiply. These cancel out. What I do to the left side, I do to the right side. Negative 9 times negative 8 is 72. And the last one, if I rewrite this problem with a variable on the left, I get y divided by 22 equals 11. How do I get rid of the 22? Since it's linked by division, I multiply. Those cancel out. I multiply. 11 times 22 is going to be 242. Okay, go ahead, check your homework answers, and then come back and let me know if you have any questions.